Yeah, thanks, Achim. Well brought together. That's exactly what we will talk about today. So I was going to say, you may have seen another presentation I held 2 years ago about holistic variant management for Polarion, but the news is in the subtitle here. I'm very delighted today to talk about the new pure variance connector for Polarion. Yeah, you already introduced us, so I will just skip that part and say I'm very happy, and I think Aina too, that we are here today, yeah, and
Yes.
can talk about this new connector. And I want to start talking about it by giving you some motivation about why did we want to do another connector? Because there is already Polarion Variants, and it's working very nice as a fully integrated variant management inside Polarion. And this will stay. This will stay as it is, yeah. And the reason we went on and now are coming up with a new pure variance connector for Polarion is that, like was mentioned earlier, we received some customer feedback that there are situations where you want to have more capabilities to model more complex variability information for systems of systems, for product lines of product lines, where you want to work with multiple feature models, control variability across multiple Polarion projects. And you might want to have variant management in a holistic way that covers Polarion assets, but also goes beyond that, also controls variability on code side, on MBSE level, on simulation level, and so on. Those are the high-level cases that basically were addressed to us by existing customers who said, well, we would like to have the possibility to get additional functionality on top of what Polarion Variants offers. And this is exactly what we want to provide. We will not replace Polarion Variants. We think both there are very good reasons for both solutions to exist, to coexist. Polarion Variants basically gets you fully covered if you want to have variant management inside Polarion for your Polarion assets. If you are fine with having one feature model for a Polarion project, you are perfectly covered. If you have advanced needs that go beyond what Polarion Variants offers, and you want to have variant management across different tools, including Polarion, then pure variants with the new connector is the way to go. And there's also a way from Polarion variants to pure variants. So it's not like you have to decide at the beginning, do I choose one or the other? But you can, over time, if you see the need for it, migrate without problems. I will come back to that during the presentation. So I mentioned some advanced use cases for which the new connector will be helpful, that the new connector supports. And here I want just to give some highlight use cases as an example. So one point where we ask a lot of time is, how do we support, or can we support parametric variability inside of requirements? So can we, instead of just controlling with features the existence of a requirement, also inject values into requirements, test cases, and so on, based on how a variant is configured? That's one of the cases that is covered by this connector. Another one is support of different development lifecycle stages of variants. So you may have one variant that's close to getting live, and another variant that is early in the development process. You might want to base the one that still has time in development on the latest and greatest reusable assets, while you might want to base the one that is going live soon on a stable version of your reusable assets. That requires that for variant generation, you have to have the capability to point at the baseline of your supersets. That's a thing that's fully covered by the connector. Also, and I will give a brief preview on that, or a brief insight on that. There are a lot of questions about how can we best get more information out of the variability data to make smart decisions in portfolio management, to make smart decisions when talking about how if we really want to instantiate another variant. And to answer those questions and also run impact analysis and so on, we have variability analysis capabilities that are usable also in combination with that connector. And yeah, we can cover, I mentioned it earlier, much more complex setups, much more complex modelings on the feature model side that is sometimes needed if you're dealing with complex systems, right? As well as support for having product lines, reusable assets out of which you can generate a reduced set of reducible assets, and then based on that, continue to configure variants and derive them in a later step. So a multi-step configuration of variants. That's also a concept that's fully supported that we here is needed a lot of times in automotive and aerospace, for example. And finally, I mentioned it, the holistic variant management approach, so that you can go with variant management beyond Polarion and also connect other engineering assets. So now that I have mentioned some of the use cases that are covered by the connector, I also want to give you a preview on it. So quick disclaimer, things might change. It's not released yet. Yeah, we are aiming releasing it at the end of the third quarter this year. But what you see here is most likely very close to what you will get in the end. Yeah, so here we go. You remember I said when using the connector, then pure variants is used for modeling feature models, configuring variants. The connection to Polarion, this still is established to Polarion assets. This is still established from within Polarion. And for that, the connector comes with an integration that shows up right inside the Polarion UI. So you see here, we have a pure variants entry in this project. And if we click on that, we can get access to a list of all of our specifications that we have in this project. And if we open them via this pure variants entry, then a view opens that presents us with the requirements document that we opened, for example, here, along with a view that loads feature models from pure variants. So we can see the feature models we have defined there, and we can make use of these features to map them to our assets, to our requirements, to our headings on the Polarion side, with the intention to make the existence of these assets controllable via feature selections when we configure variants based on such a feature model. And we also included support here to establish this mapping. So there's autocomplete functionality to write feature-based rule. For example, if we want to decide that this requirement 119 is only needed for US and Canada, we can type a rule by referring to these features combined by a logical operator. We can apply this rule and it's put right onto the requirement. And now this requirement will only become part of variants that are configured for those markets. Then let's come to one of the new use cases. This is adding parametric variability. You can now also write inside the requirements text, add square brackets to add a value that will be a reference to a value in the feature model that will be injected in there when the variant specific module is generated. For that, with help of autocomplete support, we point at the attribute in the feature model from which we shall get that value later on. And once we formulated that rule, in this case, we will get the value from the attribute pulse below the feature DLL LED. This value will be injected and will replace this square bracket with this expression inside when variant-specific output is generated based on this superset of requirements. We also included preview capabilities. So right from within Polarion, you can now select out of a drop-down menu here in the side view a variant that you have configured by feature selection. You see which features are active in this variant. If attributes are part of the model, you see also the values these attributes have for this variant. And by clicking on the preview button here, you get a preview of how this module would look like for that specific variant. So every requirement that's not needed in that variant is grayed out. so that you have an easy idea of what will become part of that variant and what not. And you can quickly switch between variants and get a preview before you actually generate anything. As pure variance is also involved in that working process, you also have to make pure variance aware once where your superset Polarion assets are located and which baseline to use to generate variant-specific output out of. I also quickly want to show how this is done. You can just via the import command import from Polarion project one or multiple documents. So just to let pure variants know they exist. And at that point in time, you can also say which baseline you want to import. That's also changeable later to tell pure variants that it shall create variant-specific output with that baseline of supersets as an input. And once this is done, we are set up to generate variant-specific output on Polarion side. So we support 3 transformation modes out of the box. One is enumeration transformation. This means we will not generate any new documents. We will just extend the existing superset documents by adding tags, so to say, to each requirement with the name of the variants that make use of that requirement. So the intention here is that while you work on the superset document and you change a requirement, you might want to immediately want to know which variants are actually using that requirement at the moment. And this way you can easily see it from within Polarion. On pure variant side, you can also see it, but a lot of times it's good to see it directly on the solution side, right? And that is intended to help you to realize that. And then we have two other transformations. The link transformation, this one generates separate documents for each of your superset documents. You will get a variant specific one for each variant. And in there, we just refer to the superset requirements, to the subset of superset requirements that is needed for that variant. So meaning, of course, that then these requirements, the subset of requirements in that variant specific document will always be in sync with your 150%. Or if you define that it shall be based on a specific baseline, then it's pointing to a specific baseline of the superset assets always. Meaning, as there is no really copy for the variant generated of these requirements, of course, then such injections of values are not supported in that case. Yeah? And you cannot change this 100%, this generated output independently of the 150%. But that might be exactly the use case. So if that's what you're going for, the link transformation is the way to use it. The copy transformation, on the other hand, that really generates variant-specific modules with copies of the requirements, of those requirements that are needed for that variant. And in there, then substitution happens. So if you have these square brackets in the requirements text where values shall be injected, this is done during the transformation, and you end up with a separate variant-specific instantiation of your requirements that you can also change manually afterwards if that is wanted. I also want to show you how this looks like then in action. So here I trigger a transformation for one variant manually. You can also trigger a transformation for all of your variants in one go. You can even do this headless or make it part of your CI. Yeah? In pure variants, so if we want to run this manually, we can just open a variant model. Before we trigger the transformation, we can check the feature selections of this variant. We can also see in a separate tab here, what is the impact of these feature selections on our requirements. So if I switch to this other view here, I can see which of my requirements on the Polarion side are included and which ones not, based on the feature selections I made. And then I can trigger the transformation I was looking for. I start with the enum transformation. After that finished, I can move over to Polarion and I can have a look at my now by the enum transformation extended superset document. So you see here, for example, we have made a transformation for baseline Sweden. Hazard warning is selected, cornering light is not selected in this variant. And if we now look for the respective requirements, you can see that next to hazard warning, baseline Sweden has been added as the name of a variant who is making use of that requirement, while next to the cornering light requirements, this name has not been added by the enum transformation, as these are not needed for this variant. So if we really generate variant-specific output, then you can in advance also specify whether that output is generated into the same project where your superset requirements are located, or into a separate Polarion project. You can specify a subfolder in which this shall be created. So here we specified that all of our variant-specific requirements shall be created in the same project where we have our superset requirements, all in the subfolder called variants. And inside that subfolder, Pure Variants generates then a specific folder for the variant, and in there all the modules, all the requirements documents that are needed for that variant. So let's go to the output of the copy transformation. You can see it looks similar to the 150% document, but a lot of requirements have been removed. Here in this preview, we still keep the headings, empty headings in. This will change in the final release. We also inject here variant-specific values wherever we had such calculations included. So you in the end up with a clean variant-specific instantiation of the requirements. So this can be one, like in this example, one document or multiple documents in one go. We can also have a quick look at the link transformation output, which is here. So you can see here we really just refer to the superset requirements. Meaning here we cannot make such substitutions. So if you use link mode, better not use those substitution expressions. But here this means this will always be in sync with your 150% or with a certain baseline of your 150%. It's just like looking at the filter showing you only the variant-specific requirements, the variant-specific subset of the requirements you need for that variant. Beyond that, if you use the connector, then you are of course also free to connect the feature models you now use to control variability in Polarion to your assets in other tools, like on the MBSE side or on code side and so on. Meaning that when you configure a variant or you want to configure a variant, you configure it once via feature selection, and then you generate the variant-specific Polarion assets, the variant-specific MBSE assets, the variant-specific code, all consistently to each other based on the same feature knowledge, based on the same feature selection. And I think that's also a great thing for advanced variant management needs. To also give you an insight what all of these interesting advanced variant management, advanced modeling capabilities are that I earlier on listed, I also want to give a brief insight into those. So you can, for example, use multiple feature models. So here we have a variant project again. You see two feature models here inside in that variant project. And in Pure Variants, we have the concept of a so-called configuration space in which variant models are then created. And in that configuration space context, you can say or define which feature models shall be used to configure these variants. And the result is immediately visible if we open one such variant model, as we did here on the right-hand side. You see when you want to configure this variant, you immediately get presented the features of both feature models, the functional features up there, the regions features up there, stemming from these two different models. And you might also have spotted this. You can have relations between features of one feature model with features of other feature models. So even if you split up your features into multiple models for multiple subsystems, or like here for having functional features in one model, regions in another model, you can still put them into relation with each other with simple rules like here, or more complex rules expressing that one feature in one model requires another or is in conflict with another, or a certain combination of feature selections in one model has an effect on the other model. You can even say that one feature model is nested into another one. So an example for that would be that you maybe have a system that you describe with feature models, and in that system here you are using controller, which in itself can be a product line that has its own feature model and has its own variants. So you can nest multiple instances of that controller as a sub product, as a sub product line basically into that feature model, and can then define, for example, that when configuring the parent system, you only want to select which variant of the subsystem you want to use at this place. Or you can also decide that you actually want to configure the variant of the controller along with the overall system. And again, you can put relations between features. You can create relations between features of the subsystem and of the system, relations between features of feature models from different systems, and this all will be taken into account. And the tool will tell you, okay, you made certain decisions on system level, therefore you can only take 2 out of these 5 possible variants of your subsystem. Or you have made certain decisions in your subsystem. This means you can only use it in systems that have this system level feature. Things like that can be easily described and are auto-resolved and shown to you that there are interdependencies during the variant configuration. You can also inherit feature selections between variants. This is helpful if you have such a partially configured variant where you on purpose left open some decisions, or already excluded explicitly some features, left some features in. And then you have multiple variants like that one that shall inherit from that variant, so that in those other variants you only have to take care of the undecided features. Yeah? The reason for this could be that you want to prepare a base variant for a certain market, so that all variants that actually go to that market inherit from that base variant, and you are sure that those features are always in or always excluded for that market. Or if you are more as a supplier, active as a supplier, you might want to provide your products to different OEMs, to different customers, and you want to have such a base variant for each of your customers where certain features are already activated and deactivated. As you know, they are always in or always out in all variants for that customer. And then you can focus on the remaining open decisions when configuring out the actual variants for that customer, for that market. Pure variants, you can also let pure variants know that this is a partial configuration. Then it will deal differently with unselected features. So here, for example, you see we are in an actual configuration for 100% variant, so that shall be fully configured. And below this mandatory feature, we have multiple ones that are OR features. The meaning here is that you have to select at least one of them in each variant. Therefore, you get an error marker here. Pure variants knows you have to select a region, otherwise the variant is not valid. Yeah? So therefore, you get this error marker. If you tell pure variants, however, that this is a partial configuration, pure variants doesn't throw an error marker in this case, as it knows leaving the decision open here might be on purpose, so that you can do this in the next step with the actual variant that inherits from that partial one. And if you need this inheritance concept, this stepwise configuration, not only on feature model side, but also on solution side. So if you also want to generate out of a 150% set of Polarion assets, 120% out of which in the next step 100% are generated, then partial configuration also has you covered. So if you transform such a partial configuration variant model, then all the solution assets that are connected to such undecided features are kept in, while the ones that have been explicitly excluded, those requirements that are connected to those are already removed for the 120%. And then you can take those in the next step as the input for generating out of those to 100%. So really you have here stepwise configuration capabilities on problem space side, on feature side, as well as on solution asset side. I also talked about analysis capabilities. So I want to show at least some as well here. So consider you have a variant and you want to change it. So let's say we swap the controllers. Instead of controller B, in future this variant shall have controller A. We want to understand what's the impact of that decision. With the pure variance result view, you immediately see what impact it has in terms of other features that are activated, values of attributes that are set to a specific value based on your decision. You can immediately see on which of your solution assets this has an impact. So if there are Polarion requirements connected with that controller, they also show up in such a delta view, and you get immediately to know, okay, if I activate this feature in the variant, this means the following changes on Polarion side. If you have also connected this model to your code, it also tells you what's the impact on code side and so on. So you get a holistic view of on what impact does my decision have here when I configure a variant. You also can compare variants to each other high level. So here you can get such a similarity matrix view that shows you how similar are two variants to each other, and you can define based on what. So you can make a similarity matrix based on the similarity on feature level. So how similar are they regarding the features they have selected? Or you can type your variants, please let me know how similar my variants are with regards to Polarion requirements they reuse, with regards to the code base they reuse in common and what's different. So that is quite useful if you want to get a big overview, how similar or how different are the variants in my portfolio. Are there maybe ones that are 99% similar and I can reduce maybe even variants? And a good starting point for understanding similarity and differences. And then you can deep dive, of course. You can compare variants directly to each other, getting also delta explanations there for solution space and for problem space again. So you can see how are they different on solution side, how are they different so in the engineering assets, how are they different on feature side. And you can also just have a view on all of your variants or some specific ones in a matrix view where it shows you the feature selection of each variant in one column. If you have attributes in the model, also the values of those attributes for that variant. And if you want, you can also then look at the solution side and understand what is the impact of these feature selections on the requirements that are reused in this variant. So here, for example, I get to know that the requirement 144 is reused by all but two of my variants. I get to know that the requirement 121 is only used in one single variant. And this information is all calculated based on the feature selections you made. So even before you generate variant-specific documents on Polarion side, you get to know what would be inside. And also for impact analysis, this is nice, of course. If you detect an issue and you change a requirement in your superset and want to know which variants need an update now, you know which ones are currently using this requirement and which ones are not. So which ones are affected and might need an update and which ones not. So there are many more capabilities, but here I will stop. I hope I convinced you. So if any of those match your use cases and you say, oh yes, this is what we always wanted, then you might want to have a closer look at that connector. I briefly also want to cover some other topics around the connector. One is licensing. So
Robert, may I interrupt you here? I think I would like to take the chance to ask you or give you a question of one of our audience.
Sure.
In the context of the use of MBSE simulations or test tools, wouldn't be better to let Polarion to be the central tool where the variant-specific views or links are accessed, because the requirements are in reality the central items to which everything else need to be connected?
Well, in that case, if you want to realize that, you would have to have basically also capabilities that let Polarion control variability on the MBSE side. And so actually, that's, to my knowledge, not possible. Such a dedicated variant management tool exactly fits that case. So with pure variants, you have a tool that's out of the box connected to most of the most prominent MBSE solutions. You have a connector there. In the same way, you see we easily mapped requirements to features to then let them be controlled by that central approach. You can the same way also work with a connector for your MBSE tool to connect your superset architecture to those features to control variation points in there. So you have the consistency by having everything connected to that model in the end. And so in the end, you need at least one tool that can talk to all the others. So if you want to have that consistent reuse approach, and that is where we position our pure variants as a dedicated variant management tool, and that is why we have all of these connectors, to make this exactly happen.
Perfect. Another question: if you meet that in a later point of time of your presentation, then just stop me. But the question is, can the new connector be used for existing variants created using the current variant engine?
Yes, the short answer is yes, and I will show that in a few
Perfect.
minutes.
Good, thank you. Then let us continue.
Okay, fine. Yeah, regarding the next point I wanted to talk about, licensing. The message is we see this, and that also relates to the question that was asked just now, as a journey. Yeah, you might want to start with Polarion Variants. Yeah, so you're already working with it. You're building up your feature models, your variant models, and at some point in time, you say, for one reason or the other, I want more. Yeah, I want to have more modeling capabilities to express more complex interdependencies, or I want to reach out to and connect to assets that are located in other tools. Then we thought about such a upgrade scenario. Yeah. And that's also true on licensing side, meaning in the end, if you want to use the connector, you will still need Polarion Variants licenses. Yeah? And on top, you will need a Pure Variants floating license that gives you access to the Pure Variants Eclipse client that we briefly saw earlier, as well as to all connectors, including the Polarion connector. So meaning you basically purchase such an additional license to get to then have access to all of a solution that covers all of the use cases that we mentioned earlier. Then the good question that just was what was asked just now, I want to answer. Yes, so this means we also thought about migration. So you can indeed start with Polarion variants. You can build up your feature models, your variant models, connect your Polarion assets to those, do variant management there. And if you consider that you then want to introduce pure variants and the Polarion connector, you can import all your feature models from the different projects. You can import your variants. So they will then also be brought over to the pure variant side. And from that point on, there are no limitations anymore in those models. So then you can do all of the things I showed earlier. You can extend them once they are imported to pure variants with attributes. You can nest them. You can then use them across multiple Polarion projects and so on. You can enrich them with more complex constraints to express that there are more complex relations between them. All of that is possible. And regarding the solution assets on Polarion side, where you already wrote restrictions with Polarion variants, they can just be converted during that migration step, so that they are 100% compatible with pure variants and the connector. So basically, in Polarion variants, a subset of the language was used to write those relations, and this needs to be converted once. I think we have a different, I don't know the technical details here, but I think we have a different type of field that we store these rules in, and this can be handled via the migration gracefully, and then you can continue working with your assets, with your feature models, with your variant models, with your superset Polarion assets, but then making use of this connector and the advanced capabilities. Okay, so then maybe there's also the question in the room, when is this all available? I briefly mentioned it earlier, I remember. It's planned for the end of Q3 this year. So that's when you can expect us to deliver the solution. But we are ready now to talk to you if you have more questions about the connector, if you want to know more details here about certain workflows, about how this fits into your environment. Let us know. We are happy to share information here.